Hi, Precalculus student. This video is for chapter 5.1, angles, and we are looking at how to represent special angles in degree and radian. And I want to continue with the discussion on how to label more angles, know the position of angles in the coordinate plane from 0 to 360. In the last video, I talked about how you can write all these special angles relate to 45 degree by converting them to 3 pi over 4, 5 pi over 4, not by direct conversion though. You remember when I do 135, I don't multiply by pi over 180. I actually think about it from pi minus pi over 4 because 45 degrees pi over 4. And when I write 350 degree equal to 7 pi over 4, I don't do the conversion, but instead I think of 2 pi minus pi over 4. So I am going to do two more. Okay, so get more space. So two more special angle, which is 60 degree and 30 degree. Okay, so get more space. Oh, I think I can go down if I have, okay, so it's how to create new space like that. So the way I do it would be, let's just create some space. Would be think about not by conversion. Conversion is useful if the degree is not a special angles like 20 degree or 10 degree. But if they are special angle like in 30 degree and 60 degree, so let's use pi equal to 180 as our guideline. So if I have 30 degree, what angle how can I write it in radian? So 30 degree is 1/6 of 180, right? So I would write it as pi over 6. And also 60 degree is what? Is 1/3 of 180. So it will be pi over 3. So that would be our kind of our a standard or our baseline. Okay, so where is pi over 6? So we would say pi over 6, or let's use green. Okay, use green. Pi over 6 is 1/3 and 1/6. And then pi over 3 is in terms of 90 is 1/3 of 90 actually. So 30 degrees, think of 1/3 of 90 is 2/3 of 90. So I write this as 30 degree, and this is 60 degree, and this is 90 degree. In terms of 180, that is pi, right? So that is 30 degree, and then I label it as pi over 6 and label this as pi over 3. And we know that pi over 4 is actually right here, right? 45 degree is right in the middle, and it's pi over 4 that we talk about, but we don't talk about that now. So what are other angles that are related to 30 degree? So if you look at 180 degree and you and draw another angle here, think of it like this, but with 30 over here, so this angle would be 180 minus 30. It would be 150, right? Minus 30. And then if I think of 180 but minus 60, I have another angle. 180 minus 60 would be 120. So I have two special angle. Not very nice. Draw it. And then what about here? I can have another set over here. This would be 180 at 30. I think of this as 180 at 30. That's 210. And this would be 180 plus 60. It would be 240, right? And then I have two more special angles in the fourth quadrant. But I will think of it as 360 here as 2 pi. 360 minus 30, because this is 30 and this is 30, is 330. And 360 minus 60 is 300. So all these special angles are created by from 360 subtract, 180 add and subtract from whatever that you have in the first quadrant. Now, then we would need to write these angles in radian. Okay, how do I write this in radian? 115 radian. I'll think of pi, because this is pi minus pi over 6. What is pi minus pi over 6? That is 6 pi over 6 minus 1 pi over 6. That is 5 pi over 6. You see how I never do the conversion, but I just do subtracting pi over 6. And what is 120? This is pi over 3. So I'll do pi minus pi over 3. So you get the idea. That would be 3 pi over 3 minus pi over 3. That is 2 pi over 3. And again, I do add, right? So pi add pi over 6 would equal to 6 pi over 6 plus pi over 6. That is 7 pi over 6. So I label this as 7 pi over 6. And I label this as add pi over 3. Pi add pi over 3. Can you do it in your head? So it will be 3 pi over 3 plus 1 pi over 3. The top is 4 pi. So this is 4 pi over 3. And what about these? These two are subtracting from 2 pi. So I'm going to do the calculation here. 2 pi minus pi over 6. Can you do it? 2 pi minus pi over 3. So this would be, do common denominators, 12 pi over 6 minus 1 pi over 6. That would be 11 pi over 6. And this one would be 6 pi over 3 minus pi over 3 is 5 pi over 3. So all in all, we label all the special angle in our coordinate with radian and also angles. So the degrees are labeled here, and the whole thing is labeled here. So get used to these special angles in radian and as well as its degree, because it will be useful in 5.2 and the way how we build up the unit circle. There's the next topics that we're going to talk about in 5.1 is two concepts called coterminal angles and reference angle. Coterminal angles, you probably had some idea already, because when we sketch angle, you see that two angles may be different, but if they are different by 360, they actually share the same terminal side. So basically, they would be coterminal. Coterminal angles are two angles in the standard position that have the same terminal side. So an example would be if I want to draw 60 degree, right? And I'm going to draw 60 plus 360 would be 420. So 60 degree would be here. 420 would be, you just do one rotation and you go at 60, right? So they have the same terminal side. They actually have the same, if you put them side by side, if they put them together, they actually have the same terminals. You can't distinguish which one has this. So these two angles, they are not the same angle, but they are coterminal angle. Coterminal, because they have the same terminal side. And you can see if you do plus 360 times 1 plus 360 times 2, where k is an integer or a whole number, or minus 360, minus 2 times 360, 3 times 360, they're all coterminal. And for radian, if you plus 2 pi, minus 2 pi, they're also coterminal. So the first things, this is very important, because when we define a trig function, how do we know that it repeats? It repeats because they are coterminal. Find one positive and one negative angle coterminal with the following. So the positive would be plus 1 time of 360. So 480 is coterminal with 120. If I minus 360, so that would be negative 240. That is also coterminal. What about negative 900? So if I add 360, I have another negative angle, right? What is 900 minus 900 plus, okay, negative 900 plus 360? That would be negative 540. But if I don't like this, I can actually add 360 again, right? So I add 360 again. I end up having negative 180. This is a negative angle that's coterminal with that. What about positive? This is still negative. I need another one, so I would just add 360 from that again. So negative 180, add from it again, so I have 180. So 180 degree is actually coterminal of negative 900. What about these that are measured in radians? They don't have the degree, that means they are in radian. So I would minus 2 pi, right? 2 pi is actually 8 pi over 4. So that would be 19 pi minus 8 pi over 4. That's 11 pi over 4. So that is one that is positive. But I can actually go more, minus 2 pi again, because this is still not within 0 to 2 pi. So minus 8 pi over 8, so it will be 3 pi over 4. So this is one positive. I can give the answer for this or this. They're both positive. But if I want to get a negative angle, so we start off with 3 pi over 4 and minus 2 pi. So that would be 3 pi over 4 minus 8 pi over 4, right? Because convert this into a common denominator of 4 will be negative 5 pi over 4. So this is the negative, this is the negative, and this is the positive. About negative 70 pi over 6. So this is negative. I can just add 2 pi to see what happened. So add 2 pi means negative 70 pi over 6 plus 12 pi over 6. You see how you always do fraction. It's negative 5 pi over 6. That's good. So this is one answer that's negative. What do I want a positive? Oh, I'll just continue adding, right? So sometimes if if you add 12 pi, so you have 7 pi over 6. So that is one positive, one negative. If you want a positive, you just keep on adding 2 pi or 360. If you want negative, you keep on subtracting until you have a negative. Another terms that we want to talk about is reference angle. Reference angle is used, is one of the things that we use to construct the unit circle later on. Not much useful after we construct the unit circle. But we need to know like what it is about. So reference angle, theoretically, if your original angle is theta, theta prime is called reference angle. So it is the smallest acute angle formed by the terminal side of theta and the horizontal axis. So we look at the horizontal axis. What happened is later on we would draw a triangle so that we can use Pythagorean theorem on the horizontal axis. And if your angle is greater than 180, like this, you cannot draw a triangle. But so what happened is we want to draw a triangle that it has the base always on the x-axis. So if the angle is in the first quadrant, your reference angle is here. So if my theta is 20 degree, theta prime is 20 degree. The reference angle is 20. If your angle is in the second quadrant, so the smallest angle would be the one that is on the other side, a supplement to the original angle. So theta prime is 180 minus theta, right? So for example, if theta is let's say 150 degree, what is theta prime? Theta prime is 30. It's the angle that it's make it to the horizontal axis. And then if it's in the third quadrant, you subtract 180 from the angles to have this angle. And if it's 360, you look at the difference between that angles and 360. So let's look at the reference angle of this. Where is 108? 108 is here, right? So it's here. So my reference angle would be 180 minus 108, that equal to 72 degree. This is theta prime, right? What is 310? 310 is kind of here. So this is 310. What is theta prime? Theta prime is the gap between 310 and 360. So we have 360 minus it, so that's 50 degree. It's always an angle that's less than 90. And what is 200? 200 in the third quadrant, like that. So it's the difference between the angle itself and 180. So I get 200 minus 180, that's equal to 20.